Hello guys, in my previous video I have explained about mesh analysis and also I have explained about the procedure for finding unknown parameter by using mesh analysis. So I have concluded that if any circuit is having more number of voltage sources compared to current sources, then you can apply what? Mesh analysis. This is our first point. If any circuit is having more number of current sources than voltage sources, then you can apply what? The nodal analysis. Now and at the same time you can apply mesh analysis only for what? Planar circuit, but you cannot apply mesh analysis for what? Non-planar circuit. Now see, here we are going to solve one problem by using what? Mesh analysis. Now in this circuit we need to find mesh currents using mesh analysis. Now thing is, first, can you apply mesh analysis to this circuit? How many voltage sources and how many current sources are present? We have only two voltage sources, we don't have any current sources. Then you can apply mesh analysis. Is it a planar circuit or non-planar circuit? Yes, it is a planar circuit because you don't have any crossover. Then you can apply mesh analysis. So before apply mesh analysis, I told you that you need to observe how many loops, how many closed circuits you have. Those many mesh currents are flowing, right? So here we have how many? Two loops or two closed circuits. That means you need to consider two currents, two loop currents. Okay, now here I am going to consider that I1 is flowing in this closed circuit in a clockwise direction and I2 is flowing in this closed circuit. Okay, the current direction is up to you. You may consider clockwise direction or anti-clockwise direction. So based on your current direction, you need to consider potentials for what? Resistors, right? Or elements. This current is flowing like this, so plus to minus. I1 is flowing like this, plus to minus. Now after considering loop current and after considering the potential, higher potential and lower potential to the each element, then you need to apply what? KVL in loop 1. So you know about KVL, right? Kirchhoff voltage law states that the algebraic sum of all branch voltages in a closed loop is equal to 0. Then here the current is going from minus to plus, therefore plus. Here what is the voltage at this branch or source? 10. And here plus to minus, what is the voltage at 5 ohm resistor? You can find using Ohm's law, V equal to IR. What is the current flowing at 5 ohm? I1, because this is, we assume that I1 is flowing. R means what? 5. Therefore here plus to minus. Now here if two currents are flowing, you can write I1 minus I2 into R. Yes or no? Yes. Therefore plus to minus, what is the resistor value? 2. Then here as you applied KVL in loop 1, you need to write I1 minus I2. Why I1 minus I2? Because I1 current is flowing in this direction and I2 current is going in the opposite direction. So two currents are flowing in 2 ohm resistor. So as you applied KVL in loop 1, I1 minus I2 equal to 0. Then you just simplify this one. 10 minus 5I1 minus 2I1 plus 2I2 equal to 0. Now you always need to write I1 terms, I2 terms and constant term. So here you have I1 terms minus 5 minus 2 minus 7 I1 plus 2 I2 and plus 10 equal to 0. Now can I multiply with minus? Of course. So if I multiply with minus, I will get what? 7 I1 minus 2 I2 minus 10. So this minus 10 I am taking to the right hand side. This is what? My equation 1. 7 I1 minus 2 I2 equal to 10. So I get this equation after applying KVL in loop 1. Now apply KVL in loop 2. So if I apply KVL in loop 2, what happened? Now I need to consider the potential based on your current. So current is flowing like this, therefore plus to minus, and current is coming like this, I2 current plus to minus, and you should not change the potential for the sources, either it is a voltage source or current source. Now here plus to minus, minus, what is the voltage as 2 ohm? V equal to IR. What is R? 2. And how many currents are flowing? Two currents, I2 and I1. Now this time I will write I2 minus I1. So here I have written I1 minus I2 because I apply KVL in loop 1, and here I have written I2 minus I1 because I apply KVL in loop 2. Therefore, plus to minus here, what is voltage at 10 ohm? V equal to IR. Only I2 current is flowing, therefore 10 I2. And here what is the voltage of at particular this branch? This is the voltage source. Plus to minus what? 50 equal to 0. Therefore, now you just simplify this one, multiply inside, minus 2I2 plus 2I1 minus 10I2 minus 50 equal to 0. Therefore, always you need to write I1, I2 constant terms. So here you have 2I1 and minus 10 minus 2 minus 12I2. And if I take this 50 to the right hand side, it will be what? Plus 50, okay, equal to 50. Now can I take 2 common from this? If I cancel 2, 2 ones and 2 6 and 2 25, okay. Now therefore I1 minus 6I2 equal to 25. This is my equation 2. Now here what is our goal? We need to find mesh current, okay, I1 and I2. Then you have what? Two equations, right? So by using equation 1 and equation 2, you can find I1 and I2. Okay, I already told you about what? Cramer's rule, right? So by using Cramer's rule, you can find I1 and I2. So here I1 equal to what? Delta I1 by delta, and I2 equal to what? Delta I2 by delta. Now how to find the delta? You need to write I1, I2 terms from equation 1. So what is the I1 and I2 terms? 7 and minus 2. Okay, 7 minus 2. This is I1, I2 variables. Now I1 and I2 from equation 2. What is I1 variable? 1, and I2 coefficient is what? Minus 6. That's it. Now you need to find the determinant of delta. Okay. So 7 into 6, this is what? Minus 42. Okay, here we have 7 into 6 minus 42. When you are multiplying this one, you will get minus. Therefore 1 into minus 2 minus 2. Therefore minus minus will become what? Plus 2. Therefore you will get what? Minus 40. This is what? The determinant of delta. Now you need to write delta I1. Delta I1 means what? In place of I1, see this 7 and 1 are what? I1 the term. So instead of I1, you will write constant values from equation 1 and equation 2. What are the constant values? 10 and 25. Now you will write 10 and 25. Now you need to write I2 values. Okay, what are the I2 values? Minus 2 and minus 6. See here in the delta, instead of I1 values, I have written constant 10 and 25. Remaining minus 2 minus 6 I have written here. Now you find the determinant of delta I1. So therefore 10 into minus 6, you will get minus 60. So when you multiply from down to up, you will get minus. Therefore 25 into minus 2 minus 50 minus minus will become plus. Therefore minus 10. Now here delta I2. Okay. So now what we need to do, instead of I2 terms, you need to write the constant values. What are the constant values? 10 and 25. And this 10, 25 you need to write instead of I2 terms. What are the I2 terms? Minus 2, minus 6. I have written 10 and 25. Now I1 terms are same. What are the I1 terms? 7 and 1. Okay, now you need to find the determinant of delta I2. Therefore 7 into 25, you will get what? 175, and this is what? Minus 10. Therefore you will get what? 165, and this is the determinant of delta I2. Now you know delta I1 and delta I2. Let us find I1. I1 equal to what? Delta I1 by delta. Here delta I1 is what? Minus 10, and delta is what? Minus 40. Therefore minus minus will get cancelled, 10 ones and 10 fours. Therefore I1 equal to what? 0.25 ampere. 0.25 ampere. Therefore here I2 equal to what? Delta I2 by delta, whereas delta I2 is what? 165, and delta means what? Minus 40. Now here if you cancel this one, you will get what? Minus 4.125 ampere. Okay, clear. Now see, once if you find I1 mesh current and I2 mesh current, you can find any parameter in the circuit. For example, suppose I want to find what is the current at 5 ohm resistor. Now what current is flowing at 5 ohm resistor? As per our assumption, I1 current is flowing. So current at 5 ohm resistor is what? I1. I1 current is what? 0.25. That's it. Now what current is flowing at a 10 ohm resistor? As per our assumption, what current is flowing? I2 current is flowing. What is the I2 current? Minus 4.125 ampere. Okay, clear. Now what current is flowing at 2 ohm? Now see, if you consider from loop 1, what current is flowing? I1 current and I2 current. So I can write current flowing at 2 ohm is I1 minus I2. So what is I1 current? So 0.25 and minus this is 0.4.125 minus minus will become what? Plus 4.125 ampere. This is the current flowing at 2 ohm resistor. Okay, now everything is fine. But say current will be in the positive, right? Current may be 1 ampere, 0.5 ampere, 2 ampere. But why I have get minus 4.125? How can I understand this one? That means, see, I2 current is flowing what? In the clockwise direction. So whenever you get minus, what you have to understand that your current, actual current direction is what? Opposite to your assumed current direction. So as per your assumption, current is going in this way, clockwise. So here you get what? Minus 4.125. That means the current is not going in the clockwise direction. The current is going in the anti-clockwise direction. So here you get what? Positive 0.25. Therefore, your current direction assumption is what? Correct. The direction is what? Correct. Now 0.25 current is coming like this, and what? 4.125 current is coming like this. These are the positive currents. Okay. Whenever you get minus, that you need to understand your assumed current direction is what? Opposite to the actual current direction. Okay. I hope you understood how to find mesh currents by using mesh analysis. Okay. Thank you. Thank you so much.